Hello everyone, welcome to Shivam's classes. In today's lecture, we are going to start with the chapter Determinants. This is a chapter 4 of class 12. So let's start the chapter. So first of all, let's start with a definition. This is a definition given in your standard textbook, and it says what is a determinant. So determinant is a number with real or complex which is associated with a square matrix. Alright, so let me again start with the definition. So it says that to every square matrix A equals to Aij of order n, we can associate a number real or complex called determinant of the square matrix A, where Aij equals to in and jth element of A. So what do we take out from here is, first, determinant is a number. Alright, determinant is a number. Basically it's a number. Alright, it's a number, real or complex. Alright, it's a number which is real or complex. First of all, it is associated with, second thing is associated with the square matrix. Alright, so only square matrix that is associated with. Alright, and so what it gives is, it is associated with the square matrix of order n could be 1, could be 2, could be 3, anything. So all these square matrix will have a number associated, which is called a determinant, is what is the definition. Alright, to understand it in a different way, we can understand it like more like there are many square matrices like Aij, then there is another one like with order say n, this is Aij with order 1, Aij with order 2, and so on and so forth. And then on this side there is a number, all numbers say 5, 10, 15 or something like that. So, and you can assume that this is more like a function. So you input the value, input a square matrix and get a number out. So maybe Aij is associated with 5, Aij would be associated with this and this. Alright, so a square matrix will give you an output like a number which could be a real or complex and which will be a determinant. So this is kind of a definition. Let's understand it in more concrete manner. Alright. So let's say you have got 1 by 1 matrix like this. This is a square matrix of 1 by 1 size, right? So what would be a determinant of it? So how we first of all represent a determinant? We represent a determinant, say this is your A matrix. So we call it determinant of A like this. We use two parallel lines like this. It's just like modulus, but we don't call it modulus. We call it determinant of A, and in this case this will be just 2. So you see that there is a number which is getting output over here, right? Now let's say this is now A1, and now I have a 2 by 2 matrix, something like 1, 2, 3, 4. So how a determinant of A1 would be written is like this. Determinant of A1 would be written like, we will multiply this with this first, 1 into 4, and then we will multiply 2 into 3, and then we will subtract. So basically, if I put it in generic term, if it is A11, A12, A21, A22, then my determinant here would be A11 into A22 minus A21 into A12. Alright, and as you can see here, if I can just multiply 4 minus 6, I'll get a value minus 2. Again a number. Alright, so this is again a square matrix. You can see it's a square matrix. Just to remind ourselves over and over, a determinant is associated only with a square matrix of order 1, 2, 3 and so on and so forth. So we have done it for order 1. This is for order 1. This is for order 2. And we will now define it for order 3 also. Alright. So now let's say in a very generic manner, I will write A equals to what? I'll write A11, A12, A13. Alright. A21, A22, A23. and A31, A32, A33. Alright. Now also let's understand this in more detail. So we will call it row. This will be row, just like our matrices. So we'll call row 1, row 2, row 3, and we represent it using I, right? Just like our matrices, right? This is I equals to 1, this is I equals to 2, this is I equals to 3. And similarly, this will be my column 1, column 2, and this will be my column 3. And we'll call it j equals to 1, j equals to 2, and j equals to 3. Alright, just like the one. So this is a matrix, and we know this is how we used to do, right? And we could have easily written it like Aij, right? And of course, I would be, it's like 3 by 3, right? So now in this case, how do we determine the determinant? How would we write a determinant? So what we do when we have to calculate the determinant, we expand it along the row or along the column. So what do we do? The simplest one is, we will write determinant of A would be defined like this. It would be defined like minus 1 to the power I plus j. Alright. So this is, we have to take the signs as well, and I minus I to the power I plus j into A11. I'm not putting the value here, but we know that here I equals to 1 and j equals to 1, right? Similarly, then A11, when you take A11, what you got to do is, you have to just assume that this part is not there, this part is not there, and then you have to take this entire thing. So you will have to write A22, A23, A32, and A33. So this will be your first part. Then second part would be plus minus 1 to the power. You have to write again I plus j. I'm just using here. If you take this part, what will be your I? Your I will be 1, and what will be your j? Your j is 2. So this is I plus j. This is 1 plus 2. Alright. Now again, what you got to do is, you have to simply take this part out, and whatever is remaining, you have to write. So you have to write A21, A23, A31, and A33. So this is the second thing. And then the third part would be minus 1 to the power. You have to come here now. A13, what is I here? I is equals to 1 and j equals to 3. So 1 plus 3 I will write over here. And then if I have to take the values, what I have to do? We have to remove this part, and whatever I am left with, I will have to take. So I will have to take A21, A22. So I will have to take A21, A22, and then A31 and A32. So this is what here I will be having. Now you further simplify it. So here this was minus 1 to the power 1 plus 1, right? So it is minus 1 to the power 2. I am just again writing. And here we have just learnt in 2 by 2 determinant. What do? We'll multiply this and subtract, multiply this, right? So we'll write A22 into A33 minus A23 into A32. This is the first one. Now minus 1 to the power 3 will be minus, so I'll have minus here. I have just missed out writing A12 over here. I have to write A12 here, and I have to write A13 over here, right? Just like A11, I have to write A12 and A13 also. So now I have A12 here, and then multiply A21 to A33 minus A23 to A31, okay? And then finally, this is minus 1 to the power 1 plus 3, this will be minus 1 to the power 4, so it will become plus 1. So again, I am not writing plus 1, but rather A13, and then finally multiplying A21 with A32 minus A22 with A31. Yeah. So this is how you calculate. Once you calculate you will get the expression here, and it will be more like a number on an expression you will get. If say inside this determinant you have only cos theta, sin theta, things like that, then once you solve it, you will get something in terms of sin theta, cos theta only, right? Alright. So this is one way of doing it. Okay. You further simplify it, so you can write a22, a33 minus a23, a32, then minus and here too a11 is missing probably. So you have to write a11, right? So you have to multiply a11, a11, right? So all that you got to expand a21, a33 and plus of a12, a23, a31 and so on and so forth, plus a13 into a21 into a32 minus a13 into a22 into a31. Alright, so this is the entire expression. Once you solve it, you will get the value. Alright, now there are two more things why I need to tell you. One is that, say if this is your determinant, what is a matrix like this, you have got a11, a12, a13, a21, a22, a23 and a31, a32, a33. So I can get the value of determinant by expanding it either along this row or along this column or along this column or any other rows or column, right? I can do for any of these, but we have to remember only expansion should happen once. So either expansion should happen along this row 1 or expansion should happen along this column 3, right? Or expansion should happen along column 2. So how do we determine along which we should expand, right? And moreover, you will know that all the time you will get the same value. I am not going to do the entire derivation over here, but once you do this expansion along, say along this one, you will still get the same value of determinant like this only, whatever we have got in the previous slide, right? So you can try expanding along this. Only thing you have to remember that what should be the value of minus 1 to the power I plus j, depending on which row and which column you are on, right? And then you will be able to get. So there is one other thing for 3 by 3 matrix. We generally remember like this, that if you can just write, the first one will be positive, second one will be negative, positive, negative, positive, negative, positive, negative, positive, negative and positive. Why it will be that way? Because see here I plus j would be what? Even number here. So wherever it is coming as even number, you will get a positive. Wherever it is coming as an odd number, you will get a negative. So if you can remember like this, whether it is even or odd, then you know that what should be the value of basically minus 1 over here. What will be the value of minus 1 is depending on how you expand it, right? So this is we got to remember. And the another thing which we need to remember is how do we determine along which row or column we should expand. So we should always look for the rows or column where we have got maximum number of zeros. So what I mean is, for example, say this is your matrix. Let's say matrix A is given like this, that 1, 2, 3, 4, 5, 6 and you have got 0, 0 and 1, right? Now in this case you should not expand along this, but rather expansion along this will be helpful. Why? Because you can see if you got to calculate determinant of A, when you are expanding along this one, so you can just write 0 and 2 and then whatever be the value 2, 5, 3, 6. So multiplying by 0 will return 0. Again this one plus or minus whatever 0, I know that it should be minus, so 0, and then again if you take this, it will be 1, 4, 3, 6, but you don't have to write because you know that multiplying with 0 will be returning you 0. And then finally you have to just calculate this one, 1 into 1 into 1, 2, 4 and 5. So the value of this determinant would be simply 5 minus 8 equals to minus 3, right? If you had calculated along this, then you would have calculated 3 determinants and would have been a little difficult for you to do it, alright? So these are some of the things which we have to keep in mind while we are solving the problem, and with this we can actually be able to solve all the problems given in your chapter. Alright, the last thing which you got to remember, if you look at the determinant, so say you have got a determinant, a matrix like this, you've got a matrix A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, right, something like this, and you have to calculate a determinant, right, determinant. So this determinant, when you calculate, right, it would be something like this. You have to write 1, 2, 3, 4, 5, 6, 7, 8 and 9, and in this, this part is like this, right? Just remember, matrices would be having this kind of bracket and determinants would be having two parallel lines with no angles at all, alright? So in this case, say if I multiply an element by 3 over here, assume that I am multiplying 3 inside, so 3 into 1, 3 into 2 and 3 into 3, and I am writing 4, 5, 6 like this and 7, 8 like this, right? So this will be nothing but you can just take this 3 out as well, and if you call it a determinant, so say this is my B, call this B. So the relation between A and B would be, it will be 3 times A, alright. So what happens here is that along a row or along a column, whatever you have a common factor, you take it out. So in matrices, it had to be in all the rows and columns. Here it is only along one of the rows or one of the columns, and you will be able to take that out, alright. So in this case, this B determinant would be equal to 3 times J of determinant, right? So this is another thing which we have to keep in mind while we are calculating the values of determinant, alright. With this, probably we can solve our exercise 4.1. So what I'll do is, in my next lecture, I will try to solve exercise 4.1, and we will be making use of all these properties, alright. Finally, you will also see a determinant being represented like this, like delta. So generally we represent a determinant with this also. We also write sometimes like determinant of A as well. Sometimes we write like determinant A. So there are various ways and more like this also. So these are some of the ways of writing determinants, right? So yeah, with this I am concluding my introduction lecture of determinants. We will look at the problems of exercise 4.1 in the next lecture. Thank you so much for watching this video. If you have any queries, please do ask me in the comment section below and I'll be happy to answer. Thanks again.